Assalamu alaikum and welcome back everyone, chapter 4.4 of the Arduino series. In this video we're going to cover buzzers. I'm going to go over two circuits. The first circuit just goes over how to activate the buzzer and how to control its loudness, and the second was actually using it into a circuit that involves a potentiometer and an LED. Now looking at the anatomy of the buzzer, you see that on top of the surface is a positive symbol, and if there's no positive symbol you can identify the positive terminal by looking at the longest pin. This one is the one that receives the power input. Now the shortest pin, or the one that has no symbol, is the one that should be grounded. And knowing this, you can tell that the arrangement of pins in the buzzer and LED are similar. Now the equipment you're going to need for this video is a breadboard. You're going to need 4 male-to-male jumper wires, a resistor, LED, the buzzer. You're going to need 3 female-to-male jumper wires along with a potentiometer. Now the first circuit is quite basic. You can either choose to use a breadboard or you can choose to use the 2 female-to-male jumper wires directly, where you have to connect the positive pin to pin 10 or any of the PWM pins and ground the negative pin. And I'll show you the code after I finish the second circuit, or you can skip to the timestamp. Now the purpose of the circuit is to take an input from the potentiometer and use it to control the amplitude of the buzzer or the light emitted from the LED. And the LED acts as a visual indicator to see how loud the buzzer is. Now to start off, we connect the potentiometer. If you don't know how to use or connect it, there's going to be a link in the top right banner where it will take you to a video that I've made explaining how to use it and basically put it into a circuit. And for the signal pin, I've chosen the analog input pin A0. And since we're using analog output, the buzzer and the LED have to both be connected to a PWM pin. I've chosen pin 10 for the buzzer and pin 5 for the LED. Now using a buzzer follows the same format as if you were using an LED. It just depends whether you're going to make it a binary output or you're going to make it an analog output. Now the script that I've written is quite basic and I'm not going to go through it or make an explanation. However, there is one key point about it that I want to mention, and it's in the amplitude within the analog write command. You have to make sure that the value you're going to give it, if you're going to give it a fixed value, is between 0 and 255. It's not between 0 and 1023. And I'll explain why this is the case, along with how to use it with the ADC analog input values. Now for this script, it's going to be a little bit different. We're going to be using graphs to find out the actual value of the analog output. But it's very simple, and we're only going to be doing some basic graphing and plotting. Now to start off, we'll begin by the variables. You want to make sure that every single pin has its own variable. Next, I made another one called analog input. This is going to receive the data and store it from the potentiometer. And under it, there's one called gradient. I'm going to explain how we calculated this using the graph. And analog output is going to be the value received when multiplying the gradient by the analog input variable. And since I'm going to be presenting something on the serial monitor, I'm going to make a command for delaying the loop. In the void setup, I begin by telling the Arduino that I want to activate the serial monitor by using the command serial.begin with the baud rate of 9600. Both the buzz and LED pin are going to be output, and that's why I used pin mode output. And since we're going to be receiving data from the potentiometer from an external source towards the Arduino, potentio pin, or the pin A0, is going to be an input. Now in the void loop, I come and I define the two variables I did not define. Analog input is going to be equal to analog read potentio pin. This is going to read A0, the value generated from the potentiometer. Analog write is going to be, as I said before, gradient multiplied by analog input. I was able to derive the gradient by plotting a graph, analog output against analog input. Analog input is in the x-axis because I'm able to control it, making it the independent variable. And as I change the independent variable, the analog output changes along with it in a ratio. Now that ratio is going to be our gradient and what we're going to look for. And since you can see that the line is linear, we can just use y equals to mx plus c. C is going to be the y-intercept and it's going to be 0, so we can ignore that. And to find m, it's going to be y change over x. The highest value of output is going to be 255 and the highest value of analog input is going to be 1023. And substituting them into the y change and x change, we get the value of 0.249. And substituting the name of the axes in the formula, we understand that if we multiply the gradient by the analog input, we will get the analog output value. And that's it for finding the gradient. And using the command analog write, I told the Arduino that I want the pins for the buzzer and the LED to be turned on or have an analog output equivalent to the analog output variable. Now I'm actually not going to add a delay command just so I can see the analog input value from the potentiometer change as fast as possible. And also if you were to add, you would also change the response time of the buzzer and LED. I just noticed a mistake that I had. If the data type for your gradient was int and not float, then it will not work because the value of the gradient is in decimal and you have to change it to float in order for it to work. Now going and opening up your serial monitor, you will be presented by the analog input value. And note, I'm not going to increase it all the way just because of how annoying it really does get and it does disturb the people around me. But if you do notice, if you bring it up around halfway, that you will start noticing an increase in the amplitude. That is around halfway and bringing it back down. So it is a little bit annoying. I don't really see a practical use for it, but it can work as an alarm. Now you can use the buzzer to make a clicking sound, which would be more practical and bearable than this annoying pitch that it generates, and this is achieved by turning it on and off real quick. And this, along with the use of delay commands, you can also communicate in Morse code. If the video has helped you in any way, consider giving it a like. And if you wish to get closer to the community that I'm trying to build, there's going to be my Discord linked in the description, where you can ask me questions about any confusions that you have, or if you wish to access the code that I've used through this video, you can also find it there.